Hello, everyone. We're going to take a look at problem number 7 from WAMAP Unit 3. This is Math 55. And we're solving for x, and in this case, x has fractions as the coefficient. Let's move it around. So there's a number of different ways to approach this problem. You can just jump in and start moving things around and subtracting, or you can, if you want, because these are fractions, we can convert them all to have the same denominator, and that might make it slightly easier to work the problem. So I'm going to go ahead and do that. We have denominators here of 2, 4. We have a whole number, so the denominator could be considered 1 and 6. And if you were to do a prime factorization of each of those, 2, the prime factorization is 2. 4, you're going to get 2 times 2. 6, you're going to get 2 times 3. Oops, 6, and then 2 and 3. And so prime factorization would be the denominator that would work for all 4 numbers would be 3 times 2 squared, which is 3 times 4, which is 12. Right. So 12 would work as a denominator for all these fractions, so that we could work with them quickly and easily. So what you can do, you can convert fractions to equivalent fractions without changing their value. So if we were to take this first fraction, and we want all of these to have a denominator of 12, we can multiply the top and the bottom by 6. And this one we can multiply the top and the bottom by 3. And the whole number we can multiply by 12 over 12, assuming that 2 can be written as a fraction as 2 over 1. And then 5 over 6 can be written as multiply the top and the bottom by 2. And we end up with 30 over 12x plus 9 over 12 is equal to 24 over 12 plus 10 over 12x. Okay, now all the fractions have the same denominator, which means we can add and subtract them more easily. So let's go ahead and see how that works. Let's get a different color. Let's go with green. We want to keep x positive if possible, so let's subtract 10 twelfths x from both sides. And 10 twelfths x minus itself is going to give us 0 on that side. And over here we have 30 twelfths x minus 10 twelfths x. So 30 twelfths minus 10 twelfths will give you 20 twelfths. 20 twelfths x. And that plus 9 twelfths is going to be equal to 24 twelfths. Okay, so the fractions make it a little bit more exciting, a little bit more complicated. You have a couple more steps to remember for each step. But now we're going to subtract. We're still trying to isolate x there. So let's go ahead and subtract 9 twelfths from both sides. And 9 twelfths minus 9 twelfths will be 0, leaving just 20 twelfths x. And that's going to be equal to 24 twelfths minus 9 twelfths, which would give us 15 twelfths. Okay. So now we have this weird fraction looking thing. And we could reduce these fractions and start to play with them. What I would suggest, we want to isolate x, and right now we have 20 twelfths x, and we want to have x just by itself. And when you're dealing with fractions, the quickest way to go from some fraction of an x to one whole x is to multiply by the reciprocal. So we're just going to say 12 twentieths times 20 twelfths x, and we have to multiply both sides by that same number. And then these cancel out, right? You're going to get 1 over 1, which is 1. You get x, basically. And If you need help with this step, let's meet. We can do a Zoom room, or you can search the terms at Khan Academy, like reciprocals or fractions. And let's multiply this side. And we can do our, if we take a 5 out of here, we get 3, and a 5 out of here, we get 4. And we can take a 12 out of there and get 1, and a 12 out of here. We can do the, we can reduce the fraction before we multiply it together. So we get 3 times 1 over 4 times 1. And this is a pretty slick little method. We find our answer, x is equal to 3/4. And if we plug this value, 3/4, in here and here, and do all of our calculations correctly, those two should be equal to each other. I think that was the best way to do this. There's a couple of ways to do it. When you're picking the denominator, you don't have to do this prime factorization, but it will give you a sure answer quickly. But you may also be able to just look at these, 2 and 4 and 6. They all go into 12 evenly, so we could use 12. And then let's work it one other way. I'll start a new video and work it the other way.